Hey everyone, welcome to Coronavirus Earth Science, Day 6, Relative Dating. Alright, this is new stuff, so make sure that you are taking notes and paying very close attention. And no, it does not mean taking your sister or your brother out on a date. Alright, we are not dating our family members. Alright, before we get into it, I just wanted to remind you these are your 2 assignments that are being graded this week, okay? And I will be looking at them tomorrow morning. So please make sure that your lab is done and done nicely in your fossil, in your Geologic History folder, and make sure that your castle learning is done. All right, please. So, usually I like to start off with this fun little exercise, giving you these 5 good-looking fellas and you having to put them in age order. All right, so great conversation we can have here, being that I'm talking to myself. So, I'll just do it for you. Me, Gordon, Caraboober, McClear, and I know we all remember Mr. Stagnita. All right, so these are in age order from youngest to oldest. Now, you probably don't know our exact ages, but you were able to put us in order, right? We can say that Stags is older than Mr. Caraboober, right? I am younger than Mr. McClear. That is a relative age, relative dating. It is just a comparison of us saying this rock or person is younger or older than this rock. We're not actually using numbers, okay? So there you go. Here's our first one, relative age, right? The key word here is compared. This rock or event is younger or older than this event. All right, so those are going to be words that we use, younger or older. Okay, and you'll see this word as well, sequence, and it just means order. Okay, putting things in order. Next one, you guys should remember original horizontality. They always start out horizontal, okay? And then things happen to them, okay? Then they get folded or tilted or faulted and etc. Okay? Law of superposition. You guys have seen this one before, even last year, even in 7th grade, all right? This is the law that states that the oldest layers are on the bottom and the youngest layers are on top, okay? And if they are the youngest, that means that they happened last. And if they are the oldest, that means that they happened first, okay? Okay. Last one, it's a little bit of a mouthful, Uniformitarianism. Basically, to summarize it, it just means that the things that happen now, the events that happen now, can be explained, can be used when explaining the past. All right. So, for example, if we know that weathering and erosion happens today, we can say that weathering and erosion happened 1,000,000 years ago. Okay. If it's fair game for today, then it's pretty much fair game as an explanation as to what happened in the past. Okay. All right. So let's move on. So we know that they always start out horizontally. And this is review, then things happen to them. So this would be an example of folding. This is an example of folding so much that it got overturned. So if you go back a second to here, it says for law of superposition, if undisturbed. And that's what they're talking about, if it's undisturbed. If it folds so much that it actually gets turned upside down, then this law of superposition would not apply. So in a regions question, they would have to say, assuming the layers are undisturbed, or they'll say, assuming overturning has not occurred. All right, so that's overturning. Tilting, faulting, I hope you guys can see the fault here, right? You'll see a shift like this. All right, so here's the new concept that might throw a couple of us off. So we're talking about cross-cutting relationships, right? So we're talking about something cutting through. And these cross-cutting relationships are usually going to be younger, all right? So let's see. So we know we have R, Y, C, Z. So if we were to follow that law of superposition, right, the oldest layer is on the bottom. So this happened first, second, third, fourth, right? Now take a look at the animation. All right, so this is magma that burned through the 4 layers, right? You guys should remember what these little tick marks are. That is contact metamorphism. And that means that burning is happening or happened, right? These would be metamorphic rocks, anything that's on these little contact metamorphism marks. Now, you can see that you had your 4 layers and then you had this intrusion, right? The magma just burned through all 4 layers. Now, cross-cutting relationship says that this intrusion, which is J, has to be the youngest thing, right? It is the last thing that happened. Now, how do we know that? The way that we know it is that it burned all 4 layers. How can you burn something if it wasn't there first? Okay, and that's our method of thinking here, right? Layers R, Y, C, and Z had to be there first in order for that magma to actually burn it, okay? So that is what an intrusion is, all right? Where you have this magma and it burns through the layers. And notice that it's an igneous rock. It's cooled lava or magma, right? And the way that you're going to recognize it is that it's going to have this contact metamorphism on all sides. That means that it's burning everything around it, okay? Now, that is different compared to this, all right? So here we have our same story. We have 1, 2, 3, 4. Only now look at what happens. J burned through everything and actually came out onto the surface and cooled, right? There's no contact metamorphism on top because it has cooled and there's nothing to burn. And then a layer got deposited on it. So if we were to number these, right, let's go back to the first example. We had 1, 2, 3, 4, and then we would have 5 here was the intrusion. Okay, now look at this one. We had 1, 2, 3, 4, 5, and then 6. Layer M came last, and we know that because J is not burning it. That means it came out, it cooled, and then M came on top. There's no contact metamorphism, so that means that this is lava. This is known as an extrusion, okay? It's an extrusion, still igneous rock, because it came out of the surf, it came out of the earth, it cooled, and then rocks came on top of it, all right? Older rocks on top of it. There is only contact metamorphism with the rocks below it, all right? It will not have those tick marks on top, okay? Very important to know the difference between an intrusion and an extrusion. And then we have this, the law of inclusions, all right? And this is basically when you see these little rock fragments, and they're basically leftovers from a rock that was previous to it, okay? These exceptions are younger than the rocks that cut through it. All right. Unconformity. So, take a look. This was our example of the extrusion, right? And you know that because there is the no contact metamorphism on top, okay? So now I'm just going to take you through the animation. I'm going to get rid of the ink marks. So take a look. We have an erosional agent, right? We have weathering and erosion that's going to occur. And weathering and erosion is usually going to pick up sediment and transport it away. So look at what happens. That whole thing got wiped away, leaving this new surface. And now we have deposition on top. So that squiggly line of basically question mark, what happened there? Why is there stuff missing? That's known as an unconformity. Okay, so I know you guys are writing in your definitions on your note sheets and stuff, but I just want to take the time to explain it to you as we go through it. All right, so a definition is going to be buried erosional surface. It's basically missing information, and it's all due to weathering and erosion. Make sure that you know that. Okay, so here's another example. So let me just clear that off. So I'm going to go back. We're going to start off with horizontal layers. Then it got folded. Now look at what happens. Weathering and erosion cut off a whole lot of that. And then we had new layers on top, making this your unconformity, right? We know that there's missing information because we know that this should have done this, but it didn't. It got wiped away, and then layers E and F came on top. All right, that is your evidence of an unconformity. All right, so here are just real life examples. You had your layers, it got wiped off, and then you had deposition on top. Here you had layers, they got tilted, wiped away, deposition on top. All right, so these are where we're heading. These are the regions types questions. We're going to take these and put them in order, okay? And remember that the oldest thing is the first thing that happened, and the youngest is the last, okay? Now, when we talk about this, it says rock layer or event. It could be something that happened instead of an actual layer, okay? So, and you should remember your rock symbols. If you don't, you have your reference tables, right? So we know that this is sandstone, this is limestone, this is conglomerate, and this is shale. Now, what happened first? So I'm just going to number them. You had sandstone. Then you had limestone, which is going to be number 2. Then you had conglomerate, and then you had shale. Now my next question is, remember, it could be rock layers or event. What happened next? Are all 4 of those layers in a perfect straight line across horizontally? No, something happened to them. 5, which is the fault. And then 6 is going to be this intrusion. All right, so the oldest thing was the sandstone, and the youngest, the last thing that happened was the intrusion. And I know the intrusion was the last thing because, look, it cut through everything, right? It cut through everything. And that's how I know it was the last thing. Now take a look at the next example. This just flip-flops one other thing. All right, so we have limestone. We have shale. We have limestone. We have silt stone, and we have sandstone. Okay, so if we were to put these in order, again, we have 1, 2, 3, 4. Now, those layers are messed up, right? They're not perfectly horizontal. They have been altered. What happened next? Was it the intrusion or was it the fault this time? Now, if you look at the difference between the first and the second example, you should notice something. The intrusion came first, and then 6, the last thing, is the fault. Now, I know that because the fault cut through everything, including the intrusion, right? Including the intrusion, it cut it off. Okay, so the oldest is the shale because that was the first thing that happened. And then the last thing in this example was an event, and that was the fault. Okay, so you're just basically putting together a puzzle. You're putting together a sequence of events. All right, here's the next one. You have shale, then you have limestone, then you have conglomerate, sandstone, and silt stone, right? So we have shale, limestone, conglomerate, sandstone, and silt stone. Now here, put the story together. You know you had shale first, limestone, conglomerate, and sandstone. What happened next? Are they perfectly horizontal? That's the first thing that you should ask yourself. Are they perfectly horizontal? The answer is no. So the next thing that happened was tilting. Then 6. Did anything else happen after they were tilted? And you should say yes, because these layers don't go on forever. They got cut off. And if there's missing information, that's called an unconformity. And then 7 is your silt stone. Okay, so the oldest, the first thing that happened was the shale, and the last thing that happened was the silt stone. But we're going to do a lab on this next week on putting all of these events in order. Okay, so the next one, you have sandstone, you have limestone, you have shale, and here you have an extrusion. Now I know that because there's only contact metamorphism with the bottom layers. It is not burning the limestone. Okay, so let's put this in order. Sandstone had to come first, and that's for 2 reasons. The first reason is that it's on bottom, and the second reason is that it's being burned. So 1, the next thing that happened was the extrusion, because it burned through the sandstone and then cooled. Then limestone came, and then shale. Notice, we know the limestone came after the extrusion because it is not getting burned. There is no contact metamorphism. Okay? Last one, notice this one is an intrusion. That's the difference. This is an intrusion and not an extrusion. So let's go through our layers. You have limestone on the bottom, sandstone, shale, conglomerate, and the intrusion. Limestone came first, then sandstone, then shale, then conglomerate. That's superposition, right? Limestone's on the bottom, conglomerate's on the top. And then the intrusion happened last. And I know that because it burned and cut through all these other layers. So that's how I know it came last. Okay, so that's where we're heading. That's going to be the practice. You're going to have this map and this whole cross-section of rocks and bedrock, and you're going to have to put together a story and put everything in order. All right, so Regents questions. Describe the evidence shown in the cross-section that indicates that rock unit C is younger than D. Younger than. Meaning, how do you know C came after D? All right, so here, this is igneous rock. All right, if you guys remember, and I think there would have been a key here. It's granite here. How do you know the igneous rock came after D? And you should know this for two reasons. You have contact metamorphism, and C is on top of D. All right, so you had two things that you could have said and received credit for. C is on top, and there is contact metamorphism. C is burning D. All right, it's burning this way, so it came after it. And then the last thing, identify the letter of the rock unit that is the youngest, meaning the last thing that happened. And if you know your stuff, you should say H, because it cut through everything. Okay? So new stuff, a little bit more on the difficult side. If I went too fast, that's the beauty of this. You could pause it and go back and replay it slowly. All right, no worksheets to do. I just wanted to make sure you understand it. Starting next week, we will definitely practice this a whole lot more and have a lab. All right, make sure you get your CASA learning and your lab done for tomorrow. Enjoy your weekend. Hope everyone is safe and healthy. And I miss you guys a whole bunch. Adios.